Sometimes, after collecting a sample and already starting to work with the data, you need to add a new score to your data set. This is a question where that's happening, and I'm going to show you how that affects the mean. Now remember, the mean, the sample mean in this case, is equals to the sum of all of your scores. That's your total of all of your data over the number of scores in your sample. So changing the data set by adding a new score is going to affect everything here. It's going to affect the total, and it's going to affect the number of scores in the sample. So let's read through this and see how we're going to work this out. It says a sample of n equals to 5 scores has a mean of 20. So that's a sample mean of 20. A new score is added to this sample, and the mean is recalculated as m equals to 18. So I have a new sample mean. My sample has decreased in value with the addition of this new score. What is the value of the score that was added? Now the trick to working out the answer to this question is to realize that the mean is made up of two parts. I need the total of all of my scores, and I need my sample size. This sum of all the scores, this part here is going to be how we work out what that score was. Think about it this way. The old mean, before we added that score, was equals to 20, but it was made up of the sum of the old values over the old n. And we know that the old n was equals to how much? It was equals to 5. So we know two things here. We know that this was 20, and we know that this was 5. So considering that we know two parts of this equation, and there's three parts, we can rearrange it and solve and figure out what the sum of your old x values was. The way that I do it is like this. Let me change colors here. If I want to rearrange this so that I end up with an equation that looks like this, where it tells me what the sum of my old x values is equals to, I'm going to need to get this by itself. And to do that, you need to undo this division by n here. To undo anything, when you're dealing with an equation, to undo this division by n, you just do the opposite. So I'm going to multiply by my old n. But whatever you do to one side, you have to do to the other side. So this is going to be m old times n old. So these two will cancel, and that'll leave me with this equation. It'll be m old times n old. So I'm just multiplying the two of these together. Remember, brackets next to each other means that you are multiplying these two values, is equals to, and the only thing left on this side is my sum of x old. The little subscripts just tell me that I'm dealing with my original set of data. Now, I want it to be set up this way, but you can always flip things around with an equal sign. So if this stuff multiplied equals to the old sum of x, then the old sum of x equals to this stuff multiplied. And we know what that stuff is. That is the 20 and the 5. So I can plug those in. So I'm going to have 20 times 5. And so this is equals to 100. So I know that originally, with my original sample data, before I added that score, my sum of x was equals to 100. Okay, so now how's that going to help me? Well, let's have a look at what the new mean will be equals to. The new mean is going to be equals to the new total over the new sample size. But we know what the new sample size is. We just added a single value. So this is no longer going to be 5, this will be 6. We also know, they've told us, that the mean has been recalculated as 18. So we can figure out what this new sum of x is. We basically just would be going through the same steps that we did here. We're going to rearrange this to get to this equation. We're going to be rearranging to get to the sum of x. Actually, let me do this like this. The sum of x, my new total of all of my scores, is equals to my new mean times my new sample size. We know both of those. The new mean is 18, so this is going to be 18. My new sample size is 6. So 18 times 6 is, I believe, 108. Let me double check that. 18 times 6. Yes, it's 108. Okay, so what does that do for me? We'll have a look at the difference between the old total and the new total. It used to be that all of my data totaled up to 100, but then I added a single score, and now it totals up to 108. So what was the single score? The single score has to be that 8. There's a new 8 added to the 100, and we added a single score, so that new score is 8. So x equals to 8 is my new value. Adding a single value here changed the mean, because the mean is affected by two things: the total, and if you add anything, you're going to change the total, and the number of scores that make up the total. And so by adding a new score, you're going to change this number as well. It went from 5 to 6. The same would have been true if we had taken a score away. We not only would have taken away from the total here. So if I had taken one of the scores away, I no longer would have 100. And also, I would no longer have 5 scores. I would only have 4 scores. So you would just go through the same process. So make sure you understand this question. I'll make sure that I have another example of this in my practice questions. And I say that just because I feel like this is the sort of thing that would be perfect to ask on a test for this chapter.